Alright, make sure we are not on our iPads right now. We are looking at the bell ringer. Because guys, we got to get a little bit faster at this. We got to learn how to do it. Especially because I only got 13 people with answers in. And we're all over the place. And from what I see, we're not even remembering the formula for this type of function. We talked about this yesterday. What did I start at? 1, 2, 3, 4, 5, and 81. Was it 108? 144, 192, and 256. How long should it take us at this point to identify the type of function? Legitimately. 30 seconds. Jose, what should we notice about this function right away?
It's exponential.
How do you know it's exponential?
Because it ain't constantly multiplying.
It's not constantly multiplying? Remember, if I repeatedly multiply, what operation shows that repeated multiplication? Exponents, right? So repeated multiplication would be exponential. Can you let Haley in, please? So it's not that it's not multiplicative, it doesn't have what rate of change? Constant, additive. Tevin, headphones out. Come on. Let's see. Let's go with root 7 or 6 back there. Okay. To go from 81 to 108, that would be adding 27. 108 to 144, that's adding 36. Right away, it's not constant additive. So it's not what? Linear. It tells me it's exponential. So what is the formula that we should be immediately using if it's not linear and it is exponential? Y equals A times B raised to the x. Look at these answers up here. Do we have A times B to the x for the most part? I don't have a single one. And for those of us who are saying, I don't have time, at this point, we have got to get seated, we've got to get going, we got stuff to learn. We've got to get involved in our education. And if you know it's not exponential, or if you know it's not linear, you know it's exponential, I want to use that formula, I got to know my what? I do need the y-intercept, but to figure out what that y-intercept is, do I have the y-intercept up here right now? No? Because I need what input? I need an input of 0, don't I? I don't have that input of 0, so I need to know what to get to that input of 0? I need to know that rate of change. What's the very quick and easy way to figure out that rate of change when we know it's exponential? Z, do you remember? Okay, we need to know this. And I'm sorry that I have not gotten your Venn diagrams back to you yet. I'm trying to get everything graded, but I will get them back as soon as possible. When you get those Venn diagrams back, you're going to need to write this thing down, because this is the simplest way. Who can tell me how to quickly find that multiplicative rate of change?
Divide the 108 by 81.
Divide the 108 by 81. You take a value and you divide it by what's previous. So if I use the 192, what would I divide it by? 144. So pick up a calculator, 108 divided by 81. And remember, guys, when you're doing the bell ringer, you can hit that little calculator symbol between the tab and the escape, and it's going to allow you to do calculations. 4/3. Can I get confirmation from somebody? 4/3 from Phoebe and Sanaya? All right. So 4/3 here. Hey, what's 192 divided by 144? 4/3 as well. So what are we repeatedly multiplying by? 4/3. Every single time, you can check it. So if I go backwards to get my y-intercept, what do I need to do? Divide 81 by what? 4/3. And I will point this out, you could just multiply by 3/4 as well to do the same thing. So, either 81 divided by 4/3 in your calculator, or it'd be easier to just multiply by 3/4. Remember, to divide by a fraction, you multiply by the reciprocal. That's why I've had y'all start practicing that. What is 81 times 3/4, or 81 divided by 4/3? Either one.
I got 243 over 4.
243 divided by 4? Can I get a confirmation from somebody? Miracle, you said yes. By the way, good morning, Miracle. And? Yeah, you are. David, I missed you as well. I'm sorry. Good morning, David. And? You say it like you believe it? You just tired today? Okay. Good morning, Haley.
Morning.
And? And what?
Capable.
Yes, you are. Okay, so 243 divided by 4, and this should make sense. I want you to notice, what's 80 times 3? Or just 8 times 3? 240. So 80 times 3 is 240. 1 times 3 is 3, so 243. And I'm dividing by 4. So 243 divided by 4 times 4/3 raised to the x. If you know to divide those two numbers, the rate of change becomes very quick, and then the equation follows after that. As we got to get involved and got to get engaged in that learning process. You are super capable. You are. But we gotta get that education, get that brain moving, start thinking. All right. Let's get started with today. What are your questions about writing this equation before we continue? You thought the what? Say it louder. You thought the 81. Oh, so you did 81 divided by 108, so you got the 3/4. So I will point this out, and this is a good point. If I take 81 and I divide it by 108, I get 3/4. But if I take 81 and I multiply it by 3/4, you see how that number is less than 1? If you multiply by something less than 1, it's going to make the number smaller, right? But that number is bigger. So that's a quick gut check. And also take the time to actually do it and check yourself. If you did 81 times 3/4, you get this, not this. So you take a value and you divide it by the previous value. That's how you figure out what you multiply by. And the reason why, let me point this out. If I take 81 and I multiply it by something, right, multiplicative rate of change, I get 108. What would I do in this equation to figure out what I multiplied by? Divide by, and so I would use that reciprocal, right? Practicing that good math there. See that, Tevin? How to figure out what I multiplied by, I had to take the 108 divided by the 81. Does that help clarify that for you? That's what's happening.
Teachers, we still have a few students that haven't reported to the bus area for the field trip. Jalen Burnside, Chloe Brown, Kennedy Green, John Johnson, Kenzarius Owens, Taylor Page, Madison Reynolds, and Adrian Thompson report to the bus area.
All right. So we gotta know how to write those equations. Let's get started. Information, if you were gone, make sure you watch the YouTube video. It is posted. All right. Then we moved on to the standard form, which was y equals ax squared plus bx plus c. Once again, what did a control? The concavity, right? Once again, if a was negative, the parabola is concave down. If a was positive, the parabola is concave up. And then we talked about c. What did that value c, this constant right here, control? That was our y-intercept, right? What was the y-intercept?
The C is positive, you know, versus the Y.
Okay, so it's going up the y-axis, yes, and if it was negative, it was going down. But I'm just asking, what is c? Like, it was an actual point on that parabola. It was 0, comma c. There we go. Right, so that's why if c is positive, that parabola moves up a little bit. If C is negative, it goes down, but the focus is the y-intercept is literally 0, comma C. Every y-intercept that has ever existed has what for its x value, Miracle?
Huh?
Every y-intercept that has ever existed has what for its x value? Its input.
I'm sorry, I don't know what you're talking about.
Say it again, Grace.
I just zoned out the whole time.
Miracle, listen. What'd you say, Grace?
0.
So Miracle, every y-intercept that has ever existed has what for its input?
0.
0. Every time. That's because if I'm looking at the y-axis, notice that's an x value of -1, isn't it? To the left? That's an x value of 1. So what are the x values on the y-axis?
0.
0. Right? That's what we want to notice, that the y-intercept is always a 0, comma something, which is why if we substitute 0 in here, that all becomes 0 and we're left with a C. We talked about that and explored it yesterday. Make sure you're studying that information. When we finish up that, I believe we already started slightly unfactored form. Once again, we said if A was positive, it was concave up, the parabola is concave up. If A was negative, the parabola is concave down. Did we really get a chance to explore R1 and R2 yet? No. Okay, so that's where we're picking up at this point. And I need to get Haley set up. Preston, do I need to get you set up as well on Desmos? Okay, so I'll pull that up in a second. In the meantime, y'all have been doing this. We know how to do this. We're on slide 15. What are we adjusting in slide 15? R1 and R2. What we want to do is to see how do R1 and R2 connect to that quadratic equation, right? Or to the features, right? So R1 and R2 are somewhere there. Go find them. All right, I'm going to give you all a few minutes. Remember, explore, look for the patterns, and then discuss and see what your group has come up with. Discussion has to happen for you to grow and to learn. Okay? So Preston, oh, you already got it.
What?
Okay. Okay.
It's kind of hard to grow and learn when he don't talk. And when he do talk, he just talking nonsense.
Hey, be respectful. Z?
Exactly.
That's her point. How y'all gonna grow and learn if you can't even talk to her? Even if you're not seeing it right away, could you engage in what she's talking about and see if what she says makes sense? Because if you take the time to think and to talk, are you going to learn something? Hey, engage. She's trying to help you out. Be more respectful in the way that we say it.
Mr. Kendrick, it's okay.
You got a problem?
Yes, I was going to also let you during that 20 minutes of Matthew, those of y'all who don't have an iPad, they have it set up so you can do it. But you can, so you can work on it then as well. Come on, Tyson. All right. All right. So go to student.desmos.com. That's gonna be way easier to type. So try using Google Chrome. It's not at this.
I don't know. It just popped up like.
So enter. That's a setting that you need to change. I don't know how to change that setting. See, it keeps doing wrong. Here. You're gonna have to go to your settings here, I think. Right. Okay, try that. There you go. That's the shoe right there. Okay, so at least it's not doing that detail. We'll try to figure out. What do we figure out about R1 and R2? Intercepts or points need to be written as parentheses. So what do we think we figured out about R1 and R2? So R1 is right and left. Now it is always concave up, but remember we already talked about concavity. Uh-oh.
Yes, I did. I said it.
Uh-oh. It's no longer concave up, is it? A determines concavity, right? So we need to look again. Remember, that R1 and that R2 show up somewhere. That number is somewhere on that string. Look for it. So you want to create an account and use your school email and password. Alright, what do we notice about R1?
Oh, only the right side.
Right? Maybe hold on a second, because you're finding something with the intercepts. That bottom part. So what do we notice? So why value is what? But, well, hold on, this parabola is a whole bunch of things. And so there's a whole bunch of X and Y values. That's so look again. Where's our R1? Where do you see that? So R1 right here is one. Where do you see that? I'll say, look again. Not this vertex. Close. You're thinking about Y intercept, but a Y intercept is X intercept and Y intercept. That's intersection. So that's a plus.
Oh, I'm tripping.
X intercept. Look for R2 as well. R2. To the right? Okay. Okay, but Paul, so we're talking about left and right, but like looking at, remember, we want to find the R1 and R2 on the graph, right? Do you see the R1 and R2 on the graph? The R1 and R2 are the x-intercepts. So that is an interesting idea. It's all more about that. See if you all agree and see that pattern as well. That R1 and R2 are the intercepts. What are we seeing? What are we seeing? There's got to be more than that. Remember, everything I've asked you to look at has directly connected to one of the features, right?
Plus take both at the same time.
What are... Okay, well remember we talked about that. What controls the concavity? Only A, right? So R1 and R2 are not going to control the concavity. Look at your R1 and R2 right now. Do you see the values for R1 and R2 on the graph? Anywhere there? Where? Which points? Which points are those? Not Y, not all three, just which two? What are oh, hit the home button for me. The home button on the geek, yeah, that one. Okay, look at your R1. Where do you see the value for R1 on that graph? What is your R1? No, look at the left-hand side over here. What is your R1? Sorry. What is R1? R1 is 3. Look at your graph. Where do you see that R1 showing up? Oh, what is that called? Hold on, I'm about to talk about it. Thank you. Thank you. Thank you. Okay, so hopefully we've started generating some conversations about where we're seeing this. Hey guys, we are forgetting the directions that I gave you. Yes, we want to notice some patterns, right? We definitely want to notice some patterns, and I forgot to mention this as well. Remember, once you think you notice a pattern, what should you have done on the slides? Did we remember to go to slide 16? Where it literally says, what part of the parabola shares the same values as R1 and R2. Ooh, that should say factored form, not standard form. R1 and R2 in the factored form of the equation. What shared R1 and R2 in the, what feature? The x-axis? Can anyone add more on or clarify or push back on? Nope, x-axis, that's it? R1 and R2 on the x-axis? Need a little bit more detail with it. Think about that language. Say it one more time. The x-intercepts. Look at your R1, right? Preston, what's your R1 right now? 3. Do you see an x-intercept with a 3 there? Yes? What's R2? 7. Do you have an x-intercept of 7, comma 0? Jacoby, what's your R1? -4. Do you have an x-intercept of -4, 0? Yes? Shania, what's your R2? 3. Do you have an x-intercept of 3, comma 0? So what are we seeing out of this pattern? Remember, guys, math is the study of patterns and relationships. And yes, I'm going to ask that you learn these equations and learn how they work. But looking at patterns and relationships is going to help you prepare for the real world, because you want to identify those patterns so that when there's a bad pattern, you can disrupt it. When there's a good pattern, you can partake in it. Pay attention to those patterns and relationships. So what should we be writing here about the values of R1 and R2? So they're controlling the x-intercepts. So if I had R1 equals 3 and R2 equals -5, hey guys, we don't need to write this part that I have over to the side down yet, but I just want us to see this. If R1 is 3 and R2 is -5, what would my x-intercepts be? What would the x-intercepts be if I have these two R values? 3, 0, -5, 0. Does anybody want to push back on or add on to or ask a question about those x-intercepts? No, we're all comfy with it? Preston, you comfy with it? Jose, you comfy with those being the x-intercepts? Okay, so what if I said R1 is equal to 17 and R2 is equal to 23? What would my x-intercepts be? Okay. I need y'all to hear me very clearly on this. Hey Z, are you engaged in the conversation or are you on your watch? I need your education to matter. So, please hear me very clearly. The most common mistake that students make when writing their x-intercepts is they would write 17, 23. That's the most common mistake that students make when writing the x-intercepts. But I want you to look at that point. Why should we know that this cannot be my x-intercepts? Because 23 is the y. If it's an x-intercept, what does that y value need to be? 0. Do not forget that the x-intercept has a y value of 0 all day, every day. Your x-intercepts need to be how many points? 2 points with a y value of 0. Now I need y'all to pay attention to this as well. This is another common issue that students run into. I'm just going to let A be 2 and A be 2. So I want us to pay attention to how this equation would end up getting written if I have those A values and those roots. So remember, what is the factored form? We have it on our sheet of paper. Factored form is y equals A
X minus H.
Remember, we're looking at factored form. R1 Okay, by the way, I think I forgot to mention this. I haven't told you what R stands for yet, have I?
I'll show up an X.
You're about to ask that?
Can I guess?
Go for it.
I thought
So where do radii come in? With circles, right? Good guess. It's an R. I'll go ahead and tell you this. This is one of the few names that, as far as I can tell, has no mathematical reason why it's called this. I literally looked into it. It has something to do in ancient times with the roots of plants. It's called a root. Nope, root. That is literally why it's an R1 and R2. It's the first root and the second root, but notice those roots tie into the x-intercepts, right? So roots, x-intercepts. So y equals, based on this, what's a going to be? 2. Parentheses x minus 3. Parentheses x plus 5. Because it'd be x minus a negative 5. Remember when we dealt with the h yesterday and we had to take the opposite value for h? Notice we get x minus 3 when R1 is a positive 3. We get x plus 5 when R2 is a negative 5 because we're doing x minus. You need to be aware that when it's that x minus, you always need the opposite. Because it's the x minus, you always need the opposite. It's the only time that you need the opposite though. So, R1 and R2, yes, they control the x-intercepts. What would we write for those x-intercepts based on our roots? Based on this equation, this generic equation, what would I write for those x-intercepts? I'm talking about for this one, right? Not necessarily this specific one, but what is the first x value? Isn't it the first root? So R1, comma, 0. We have a second x-intercept, it's just going to be R2, comma, 0. Trayana, you good with that? Okay. So notice, these are our x-intercepts. What are your questions before we continue? And I do want to point this out. You can go back to Desmos whenever you want to do these explorations again and check your understanding. You can study these notes off of your task, but please take advantage of these resources. So where we are right now is you can move to slide 17 if you want to type these things on Desmos for now, but I need us to fill out the table here where I have given you 4 factored forms. I need you to identify the x-intercepts, and I need you to identify the concavity. I'm going to get a handful of students to put their answers up on the board soon, so go ahead and start working on identifying those features using the notes we've just taken. Can I get you to put your answers for the first function up there? Thank you. Say again. Oh. Have you talked about it with Z yet? Is that being respectful? Oh, you're engaging. Oh, okay.
I don't read.
So what did you but keeping it real is being rude and disrespectful and putting him down instead of trying to grow and learn. How's he gonna want to engage with you and learn with you if you're talking bad about him?
I don't think he wants to at all. I don't think so.
You ain't giving him a shot. X intercept. Why do you think negative 3 comma 0 and 7 comma?
Oh, no, it's basically.
Okay. So notice how we talked about R1 and R2.
Yeah.
And it's x minus R1 and x minus R2. So what do you think R1 is?
This is,
Even though it's x minus r1, to get x
but
minus
you
3.
gonna change it to, it gotta be opposite.
Maybe.
You gotta put 3.
Tyson, can I push you? Did you put number 2 up there?
You just gotta put in 2 points.
Thank you, sir. Looks like you got number 3 done. Can you put number 3 up there? Although I will say y'all have different answers for number 3, so I'm not gonna have that. I'll point this out for that fourth one. X minus 3 squared, isn't that the same thing as x minus 3 times what? What does it mean to square something? It's being what twice? An exponent is repeated, so we're multiplying x minus 3 by times 2 times, remember, what does an exponent indicate? Repeated what? So if I had x squared, that'd be x times x, right? So if it's x minus 3 squared, that's x minus 3 times. Remember, hold on. So 2 times x minus 3, 2 times x minus 3. That multiplication indicates it's repeated addition, x minus 3 plus x minus 3. So x minus 3 squared is not the same as that multiplication. So what does it mean to have an exponent? What am I repeatedly multiplying? Just the 3. Dude, I don't know like all of it is. 3. What is y squared? Just watch. Y times. What is an exponent? Repeated what? So I'm repeatedly multiplying y 2 times. Y times y. No, that's not. You were saying y times 2. That's 2y or y plus y. That's y times y.
Yeah.
Does that make sense now? Sorry for getting a little. Look, is that distinct? Okay. So now when I say x minus 3 squared, that's x minus 3. I'm repeatedly multiplying this how many times? So x minus 3 times. So if you write that in that way, x minus 3 times, you can find its roots. Alright, let's talk about it. No, hold on, we're going to have a whole class conversation first. So, for the first equation, we have 3 comma 0 and negative 7 comma 0.
Oh, man, I'm gonna put it concave up.
Concave up?
Yeah.
Does anybody need to, or want to push back on this, or need to ask a question? Go for it. Good question. So, Sanaya, why did you say that this was concave up?
2 in front of it.
Because that 2 is the what? A. Remember how A controls the concavity? So A is 2, and I will point this out. I'm not seeing us do this, but this could be very helpful if we just take a second to write out, okay, A equals 2. In a similar way, what does R1 equal? 3. Because it's x minus R1. Remember, we always need the opposite. I saw some of us forgetting to do the opposite here. And R2 is equal to negative 7. I also saw some people not writing it as these points. Do we need to write it as the point 3, comma 0, and negative 7, comma 0? Yes, if you did not write those points, update that. Please also write concave up and concave down. Don't just put up and down. Right? We're talking about concavity. Add that extra detail in there. Okay? The second function. We got the x-intercepts negative 8, comma 0 and 1, comma 0. And concave down. Do we need to push back on or add on to either of those? We good? Okay, third was we have concave down, negative 2, comma 0, negative 10, comma 0. Push back on or add on to or ask a question about those. Yes, Haley.
How did you get negative 2?
Great question. Who did I have do number 3? Is that Rakai? Yeah? And so Rakai, originally you even had 2, comma 0, right? So why did you switch that to a negative 2, comma 0?
Because they're positive, so you have to do the opposite.
So the simple way, remember Haley, is that I need the opposite. And that's because if I have x minus R1, what kind of number do I need to subtract so that it becomes addition? I need to subtract a negative. Do not forget that. It's not just, you just take the opposite. It's the idea that to get addition, I had to subtract a negative number. Does that answer that question, Haley? Okay, so I already heard some people struggling with the last one. Did anybody come up with the x-intercepts for the last one?
I just did intercepts, just put 3 0.
It's just one x-intercept?
Yeah. No,
Squared.
I mean, it is squared.
so it's another 3 0?
That
Could it be another 3-0? And so this is what I talked about with group 3, and I need us to pay attention to this. Hold on.
X is
Square?
So let's talk about it, right?
Makes sense.
What does it mean to square something?
Double it.
Ooh, no.
multiplied by itself.
Multiply by itself. So how are we going to write this, Jamarcus? Hold on, but it's not the same. Jamarcus, how are we going to write this?
X minus 3 squared.
Okay, but how am I going to rewrite it? Remember, how do we talk?
Same way.
X minus 3 times?
X minus 3.
There we go. Be careful. Doubling it means to multiply by 2. I am not doubling it. That's not what's happening. I am multiplying this by itself. Notice R1 is equal to 3. R2 is equal to 3. Now we'll point this out. Is that the same x-intercept?
Yes.
Yes. And so we're going to study this later. It's called a multiplicity. We technically could just write 3, 0, but then we would need to say with a multiplicity of 2. We'll study that later though. Don't sweat it right now. Just for now, I do want you to remember, technically every quadratic has 2 roots. Just whether we can always see them. So, concavity? Concave up. Anybody want to push back on it being concave up? Any final questions? Okay. So, there is, nope, go away. There is a slide here. We're actually going to do this in the book, so skip slide 18. I'm going to reflect on this information later. Go ahead and go to slide 19 and do a quick assessment of your understanding. So use the slider first, and then if you want to say any more about what's happened, then please feel free, but use that slider to indicate how you feel about this. It'll help me figure out how to help you. Hey, Preston, really quickly, just a heads up, if you unfold the keypad's easier to type on. I mean, I'm just letting you know. I know. Okay. Good job. Once you finish your reflection piece, get out your textbook. Once you finish up the reflection piece, put up the iPad, get out your textbook, volume 1, and turn to M1-51. Keep out your Desmos notes though, you will want those. Yes, run like a wind, bullseye.
You said M1 what?
M1-51. Okay. So please pack up the iPads. We do not need them any longer. Keep out your Desmos sheets. Oh yeah, we're starting a new lesson. Do you know what that means?
What?
It's time for new groups.
Man, this kid.
I know.
Just got here.
Every lesson, we're changing up groups.
This came in. This is.
I know. All right, Jimmy. Yep, taking it right now.
You finna move right now too?
Yep.
Man, you got it.
Nope. All right, who are we missing again? Just. Oh, we're not missing anybody. everybody. All right, we got 7 groups. Here are our new 7 groups. Go ahead and move Jacoby, Desiree, Cam, and Mickey in group 1. Group 2 is Jose, Naisha, Rakai, and Grace. Group 3 is Shania, Ethan, Eliza, Tyson. Group 4 is Haley, Jayla, hold on, Z, and Jamarcus. Group 5 is Tevin, Preston, Treyana, Sanaya. Group 6 is Miracle, David, Lily Kate, Hayden. Oh, that's what we're missing. Group 7 is Marshall, Jalen, and Phoebe. So find your new group. Say that again. Eliza, I think you're group 4. No, you are right where you are, Eliza. Group 3 still. What you doing, bro? Okay.
I sit in the back.
You can sit with group 4.
I'm talking about like right there.
So I will say this, if you come to, ooh, you good? If you come to class before them, definitely take some of those seats tomorrow.
You gotta tell me twice.
So,
I'm glad that I
hey,
No, tell me now.
oh God, oh God. Let's focus, okay? I know it's odd, so this is one of the things that I have done some research on recently, and this is why I'm starting to change it every lesson. There's actually research that shows I should, hey guys, whole class conversation. There's research that shows that I should change up groups more regularly. It's going to help you develop important social skills, and it's actually going to help you all learn better. I never would have thought that, but that's what the research shows. So, we should be here on M1-51. This is a lesson out of the book that I've slightly modified working with teachers around the county. The whole Desmos thing is literally an introduction to being able to tackle this lesson. Okay? So, we want to keep our notes out for it. Can I get someone to volunteer to read the first objective?
I'll read.
Go for it, Jamarcus.
I can identify the features of a parabola based on the form of a quadratic equation.
That sounds familiar. Does that sound familiar to y'all?
No.
Yeah? Oh, well not. Yeah, for the previous lesson, right? Please notice this is a practice element to what we just explored, and that's what we're doing. We're going to continue developing, so we want to have our notes out from the Desmos activity. So here's where we're starting, right? Recall that the quadratic functions can be written in these different forms. Do note, in the book, oh, by the way, this is page 54. M1-54 is where we should now be. I skipped a little getting started because we already did a lot with it. Please note that they clarify that A should not equal what? 0. And if you remember, why did I do something? Did anybody not get this sheet of paper that I passed out a second ago? What group are you in originally? Look. Okay. So some of us forgot to grab it. I should have said something. All right, Tyson. There you go, sir. Marshall. Marshall, that's how you get Marshall?
M1-54.
I did. Are you lying? Good morning, Marshall. And? There you go. Who else did I get one? Tevin. Naisha. And who else? Treyana. Okay. So, the reason why, hopefully y'all remember, Naisha put up the iPad for now. Hopefully you remember this. Whenever A was 0, what kind of graph did you see? It was linear. If A is 0, you actually no longer have a quadratic, you would end up with a linear function. Okay? That's why A cannot equal 0. But we have the graphs of quadratic functions can be described using key characteristics. Oh yeah, x-intercepts, y-intercept, vertex, axis of symmetry, concavity. Man, that looks so familiar, right? Yeah. Good, glad to hear it. Okay, so here's all I want you to do. The form of a quadratic function reveals different key characteristics. State the characteristics you can easily identify from each form. Which characteristics can you immediately see? So I'm going to give you 2 or 3 minutes to talk within your groups and identify them. If you have time to start writing them down, cool. But we need to be able to have a whole class conversation about which features we can see in each of those forms. Does that make sense? So, if you can see the x-intercept in standard form, you would tell me, hey, I can easily see the x-intercept in standard form. Not saying that's true, I'm just saying that's an example. Which feature should we see in all of them? I will say that. What controlled concavity? A. And what showed up in every single equation? A. So can we see concavity in every single equation right away? Thank you. All right, there we go. So that's what I'm saying is we're trying to identify the characteristic just from the equation. You can always see it in the graph. The question is, can you see it from the equation? I got it. So 3 minutes. Talk with your small groups. Figure out which features you can see in each form. And talk. Or sit there silently. But let's talk. Discuss. Y'all agree with that? Factor form? Can we see both x-intercepts? Okay, keep talking about it.
You don't see nothing?
A is squared though. A is squared. That's why you need to write down.
Which features can you see in each of these forms? So like, what's a feature of the parabola that we can quickly see in standard form? Y'all agree with that? So last week, talk about it with each other.
You already know what's going on.
Huh? She left, that's right, sorry guys. Come on, talk about it. What can you, we're looking.
That's a future right now. That's
Which features can you easily see in standard form? Wait, yeah, we're not on that sheet. We're on M1-54. We're identifying which features we can see in each form. Right? Yes. Did you already identify all? Okay. You identified? Let's make sure we're actually talking about it.
squared now. Ain't that good? Ain't that good? See that A squared.
So is that a feature of the parabola though? What's a feature of the parabola that the ax squared could tell you about?
Dead body.
Like, are they all going down?
Well, what's controlling the concavity? So you could say that A tells you the concavity in standard form.
Squared, I mean.
Well, remember, this x squared is what tells you it's second degree. That's what tells you that it's a parabola, or that it's a quadratic. But remember how A and C were the values that we looked at in the actual graph. The features of that graph. Does that make sense?
So you're saying A control it.
Okay, and there's one other feature you can see in that standard form.
They're about the same.
Alright, so let's talk about it. Standard form. What features can we see in standard form? The y-intercept. Can we see the y-intercept in standard form?
Yeah.
What tells us the y-intercept in standard form? C? Specifically, what would we write for that y-intercept? 0, comma C?
Yeah.
So we want to recognize that that C immediately tells us what the y-intercept is. Preston, you write this down on that page? Are there any other features of that parabola that we can see in that equation?
Yeah, the A changes the parabola.
What does it change about the parabola?
To the concave now.
Okay, so A controls concavity. Were there any other features? We need volume 1 right now. M1-54. M1-54. Okay, factored form. Actually, no, standard form. Were there any other features? That was it? Okay, factored form. What can we see?
Yeah, R1 to control the
Okay, so our x-intercepts are controlled by R1 and R2. So how would we write those x-intercepts? R1, comma 0 and R2, comma 0. So we need to identify what R1 and R2 are. Remember, if you're just seeing letters and you're freaking out, don't forget it's all based on these equations that are right here. This is why we gotta know those forms of the quadratic equations, so we know what C is, so we know what R1 is and what R2 is. Any other features in the factor form?
Nope.
Just one more.
There is one.
Okay.
What is A controlling? Concavity. So don't forget, Jamarcus, what shows up in every single equation? A. We can always see concavity from that A value. Now, please, oh, and I should clarify this. Do not forget, A is not the concavity. It's if A is positive, the parabola is concave up, and if A is negative, the parabola is concave down. We've got to remember that. So A is concavity. So if A is greater than 0, concave up, etc. Vertex form. We saying, you say line?
No.
Okay. Vertex form? Line of symmetry. What is that line of symmetry?
X equals H.
So we need to identify what H is. What else?
Vertex.
Literally it's vertex form. So,
H. Concave.
that's my vertex. And the last feature? The A is controlling my concavity again. Right? So concavity. So please hear me very clearly. These are the features that we can easily see in each of those equations. The next part of this lesson is about learning how to identify the other features as well. We're going to continue practicing identifying these features, just looking at the equation, but we're going to learn about those other features as well. Now, we don't have time to get to this, I just wanted to do a quick preview here. Please note that I gave you a sheet of paper. Doesn't that sheet of paper look pretty similar to M1-55? So the teachers that I work with around the county to build our understanding of this textbook and get better at teaching with this textbook, we redid this problem because we didn't like the way the book did it, okay? And so we're going to deal with this tomorrow, and this is going to be our first introduction into identifying other features of the parabola from different forms, okay? So, what we are going to do tomorrow is continue working in the book, getting into all of this fun stuff. And I will say that there's another card sort where we get to put stuff on graphic organizer, we get to glue things down, cut things out. So it is a nice interactive piece. But I want to give you all time to work on Mathia. Hey, listen, this may end up being our last 20 minutes that I get to give you in class to work on Mathia this week, because we need to get through this lesson out of the book tomorrow. So you have 17 minutes to get on Mathia and complete as much of Mathia as possible. So when you get those iPads out, who does not have an iPad at all? Because you don't have yours with you, David. Okay, so David, grab yourself, bring it up here. Everybody else has an iPad? So you can go to the computer lab and just go across from the check-in window. So get out Clever. Remember guys, go to Clever. So let's go to Math. Let's go to Carnegie Learning. Let's go to Mathia. So go to the computer lab and library. Go to the door that's across from the check-in window, and you can get in that way. Okay, we've already talked about it with the librarians. You don't have your iPad either, so you can do something.
You get a. My iPad on me.
Say again. You don't have a charger? So you can go to the computer lab, go in through the door that is across from the check-in window. I'm letting you know y'all on the way. Yes. Well, so, not like inside the library space, there's a door.
There's a door right there.
Yes. Working on that yet, as far as you can until the bell rings. Whatever you don't finish in class today, you may have to complete on your own for Friday. Through identifying key characteristics of graphs of functions. Okay. I think that's a total of like 3 workspaces.
Why is?
Is it all in unit 3?
Let me see.
Yeah, you work.
No, it's just unit 2. You have to complete unit 2, but notice there's 3 workspaces for unit 2. Okay? So guys, you only have to finish through unit 2, but that is due tomorrow.
How you go to that?
Go to Clever, the Clever portal.